Hello, everybody. Welcome to Speakeasy JS for this week. I'm joined today by our speaker, Dandelion, and one of our panelists, Michael. So you guys want to say hi?
Hello, everyone.
Cool, great to see you guys. So today we have a talk by Dandelion about his project SourceCred. And in particular, he's going to get really into the nitty gritty and talk a little bit about the algorithm that's used to sort of figure out how to attribute credit to contributors in open source projects. And so I'm really excited about this talk because I really think that open source maintainers should get funded and should get paid. And we need to think about sort of how to make open source a thing that is sustainable. And as an independent maintainer myself, it's a thing that I think is super important. I always love to see more experiments and more different models be attempted by different people. So it's really great. Dandelion's been working on SourceCred for a while. I think we talked originally, I don't know, like maybe it was a year and a half ago. Is that right, Dandelion? When I kind of popped into your Discord and like said hi. Yeah. So you've been working on this for a while, yeah, I'm excited to see what the latest is. So cool. So yeah, with that, let's let you take it away.
Cool. Thanks, Frost. Yeah, as Frost said, I'm Dandelion. I go by the handle Decentralion on the internet, and I use they, them pronouns. I'm the founder of SourceCred, which is a project that's basically building a decentralized economic system for open source communities. It sort of started from this realization that even if open source projects had money to distribute, we have no like transparent and fair way to figure out who in that community should be receiving the money. A lot of our economy values things based on work, where we're paying people for jobs, right? So maybe we'd say, oh, you're a software engineer, you get this salary, you're a designer, you get that salary. And that really doesn't work for these decentralized or open source projects because people aren't working on it as a job. It might be one of many things they're doing. They might be wearing a lot of different hats. And there's generally not someone who has the like role of like CEO who can decide who gets hired or fired. So we want to kind of come up with a new paradigm for valuing things, where instead of giving people a salary, we're actually valuing contributions directly. Where we might say this pull request is worth 14 cred, hosting this meetup was worth that 8 cred, whatever it might be. And so that means we need some framework for being able to assign a score, a cred score, to every individual contribution based on an assessment of how valuable it was. Now, this naturally invites a lot of great questions about like, how will this work philosophically? How will it avoid being gamed? What will the governance processes be? Where will the revenues come from? And I've talked a lot about that in other SourceCred presentations and can be answered in the Q&A. But one thing that I'm really excited to share is actually just this algorithm we've come up with. So the basic idea is we're going to organize the entire history of any project or any community into a graph of contributions. So we can think of this as being a particular contribution graph, where contributions are become relevant in as far as they depend on or reference other contributions. So here we might imagine that in the process of building a feature, and I'm going to see really quick if I can turn on a kind of laser pointer, and I won't bother with it. In the process of developing a feature, hopefully you can see my mouse cursor, we're going to actually have a lot of the things that feature depends on. It might depend most immediately on a pull request that implemented it, but it might depend also on a design doc that described the feature, and those contributions will have other dependencies in turn. Maybe the pull request depends on its code review, the design doc depends on a post that was actually proposing the feature initially. And based on this graph, we want to be able to flow cred, with the heuristic being that if you worked on a contribution that earned a lot of cred from subsequent work, then your contribution will earn cred as well. Now, a key question here is how can we distinguish between these subgraphs of contributions that actually represent meaningful work and subgraphs of contributions that were just kind of spam or inconsequential? And so here we might imagine that we've got these two graphs, these two subgraphs. One represents this valuable feature, and one is just kind of spammy work. And in this case, the spammy subgraph is smaller, but obviously the attacker could make a very large and realistic looking graph of fake contributions that just don't happen to do anything particularly useful. So this is where we do get a large bit of community governance, where we basically have a process where the community can decide which nodes in the graph are going to mint cred. And so then score kind of flows from these blessed things that the community approved of, and then propagates to all of the connected work. So here, if you did some work that was upstream of this feature, you're going to earn some score because the community appreciated it. Whereas this like spammy subgraph on the bottom, it may be a very like large and interesting subgraph, but because it wasn't approved by the community, it wasn't appreciated by the community, it doesn't earn cred. And a big important part here is that this process by which the community is able to choose features needs to be itself fairly decentralized. And so we've done a lot of thinking about like cred weighted quadratic voting and making it Sybil resistant. But let's just look a little bit more at this algorithm that assigns scores. Oh, and one more thing.
Dandelion, could I ask a question really quick?
Yeah, go ahead.
Yeah. So is this like, I guess the question is like, why did you decide to do it at the level of a feature instead of maybe like the level of like a fork? Like couldn't one like solve this problem by sort of saying, well, the spammy feature and the spammy fix and the spammy design doc don't get any cred because they didn't get merged into the main line of the project. They didn't land on master. Is that like a...
So interestingly enough, we do actually do that. We've got kind of like multiple levels of it's sort of like a defense in depth strategy where we also do say like pull requests mint a little bit of cred when they merge. But in principle, we could reframe this from being like, let's say that the spammy feature actually does get merged because it's trivial, but not useless. Maybe the spammy feature is like, oh, I went and wrote a design doc and then the design doc says the color is slightly the wrong shade of blue on the UI and it would be better if it was this other shade of blue. And then I merge a pull request. Like that did get merged. It was actually a real contribution, but as compared to a feature, which is actually much more important for users, it shouldn't get nearly as much cred. And in the limit, there's just no way for a purely automated policy to distinguish sort of superficial changes from things that are really important to the community. And that's because fundamentally software is not useful in isolation and projects are not useful in isolation. They're useful in the context of the community that values or consumes that software. And so that's why we ultimately need a governance mechanism here. And it's not enough to just have an automated rule.
Got it. Okay. So, but you still only do it sort of within a project. It's just that this feature is more about like deciding which features get the cred or get the score. Okay.
Yeah, and a goal is to make it easy for the users of the project, and in particular those sponsors of the project, to have a lot of influence about which features get cred. Because then if you're like a sponsor or supporter of the project, then you get more say in sort of making sure that your priorities are getting rewarded and are therefore like getting developed on.
Cool.
Yeah, this is like digressing into governance a bit, but I do think it's pretty important to operate on the level of community boundaries, because a system like this is going to need human oversight. It's going to need moderation, and it's much easier to do moderation if you're within a particular community. I think that once you have a platform trying to do moderation, like as we're seeing around stuff with Twitter and Facebook, it becomes really, really difficult to do that well.
Yep.
So kind of continuing with this example, we can just represent participants now as nodes in the graph. So I can go and say, the turtle, the badger, the butterfly, and the zombie are all the kind of players here. And since they are embedded in the graph, they're going to get score from the nodes that they're connected to. So looking at this and just kind of thinking, okay, if we have this property, we want an algorithm that will basically flow score along this graph so that things get score based on the score of the other things that were connected to them. Those of you who are familiar with algorithms and graph may realize that I'm basically describing PageRank. So PageRank is this algorithm that was developed by Larry Page and Sergey Brin while they were at Stanford. And it's an algorithm for giving scores to websites. And if the names Larry Page and Sergey Brin seem familiar, it's because they were the founders of Google. And so they wrote this research paper basically describing a clever algorithm for scoring a website, where a website score is based on the score of the websites that link to that website. And so it gives you this nice like property of a bit of Sybil resistance, where if I have only one site linking to my page, but that one site is like the New York Times or the Stanford University homepage. That gives me a lot of score. Whereas if I got 100 like spam sort of websites linking to me, but nobody ever linked to them, I won't get much score. So it's a pretty nice algorithm for assigning scores to graphs. It's also feasible to compute it at large scales of data, as is evidenced by Google's success using this algorithm. And so the starting point for source cred was really, what if we apply the concept of PageRank to contributions, where we're going to write plugins that automatically create graphs for a lot of different data sources. We can create a graph of pull requests, issues, and comments and commits from GitHub. We can create a graph of forum topics and posts and replies from Discourse. We can even create a graph of like messages on Discord and who is reacting to which messages, and then use that as a basis for flowing cred. So we ran into a couple issues just adapting PageRank for this purpose. The first one is score normalization. So PageRank gives you a probability distribution. So that means that all of the scores for the nodes in the graph are going to sum to 1. And a typical source cred graph will have order of like 10,000 or 100,000 nodes. And so that means that when you're looking at your score, it's going to be some tiny number like, congratulations, you worked hard, you have a score of 0.000000731, something like this. So it's not very, very encouraging to get these infinitesimal scores. So the first thing we tried doing was we renormalized it so that all of the participants' scores in aggregate would always be equal to 1,000. And then you could kind of instantly take a look at your score and be like, oh, if I have a score of 100, that means I have 10% of the cred in this instance. That's very impressive. But this problem here is that it's really zero sum. And it means that people are just going to see that as more people get involved in their project, their score keeps on going down, which is kind of psychologically demoralizing. It really doesn't set the right set of expectations where, if more people are contributing to a project, we can all make a more valuable thing together. It's not zero sum. So what we've done instead is we've taken this concept of cred minting from a few slides back where, when the community blesses something and finds that it's valuable, that creates new cred that's going to flow to that feature. And that also increases the total amount of cred. And so now we can sort of say like, oh, if we want to say every merged pull request is going to get 10 cred, that means that the user's total score in aggregate will increase by 10. And so this gets us out of the sort of zero sum paradigm for scores. Now, how does this cred minting process actually work? How is it that we're going to kind of choose which nodes in the graph are going to receive new cred? The answer is that we basically do this via what's called personalized PageRank. It's this concept within PageRank where you can make, so the example from Google search is, let's say that I want to have a search where I'm actually particularly interested in subjects relating to algorithms. And so I want to have my search results biased towards things that are from a particular subgraph that maybe is the subgraph of the internet of people talking about algorithms. There's a way where you can have it so that as PageRank score flows, it'll periodically reset to certain nodes in the graph. I feel like I'm doing a bad job explaining this. Let's look at this diagram. So the idea here is that we're going to have a special node in the graph, which is called the seed node. And the seed node acts as a sort of recycler for score, where every node in the graph is going to be flowing a bit of score back to the seed. And that's represented by these purple arrows. And then the seed node is getting to choose where to re-inject this score. And so the idea with cred minting is that when we mint cred to something, we're actually going to have this seed node that recycles all the score, flow it preferentially back to that point. And that means that wherever the cred flow kind of starts will be wherever we're minting cred. And then it will kind of trickle outwards through the graph and then eventually all recycle to the seed node. And that's why even if we were to have some, like, I don't think I put in the slide, but if we were to put a bunch of sort of spammy contributions here in the bottom part of the graph, since they're not connected to the seed node, they would not actually have much cred. And that mitigates a sort of vulnerability that you see in PageRank algorithms, which is that if you don't have this property, then it's possible for attackers to construct these little, like very dense, poorly dense subgraphs that will act as like cred traps or score traps. And because you need to get blessed by the seed node in order for your subgraph to earn any score, this approach kind of fixes that. Now, the final and most interesting big deviation from PageRank was that we wanted to add the ability to track scores over time. So, for example, I want to be able to say, you know, how much cred did I earn this month compared to last month? Well, I was working twice as hard as this month. Like, that get reflected? Am I getting more cred? And that means that we fundamentally want some way to represent the concept of time within these scores. But PageRank doesn't have any concept of time. It's just a graph. There's not really there's not even any metadata in the graph to convey the concept of time. So we needed a new way to approach this question. And the first thing we tried was what I'll call time-filtered graphs. The basic intuition is that rather than running PageRank once for the entire graph, we're going to partition this graph into little time slices, and then we're going to run PageRank once for each time slice. And then we can compute a person's total score by summing the score that they got from each individual time slice. So to make a visual example, let's suppose we have this graph and we've aligned the nodes on the x-axis according to time. So nodes on the left are very old and nodes on the right are more recent. And we're going to take a couple time boundaries, T0, T1, and T2, and T3, and use that to partition the graph. And as previously mentioned, we have this seed node, and it's kind of choosing certain nodes in the graph to inject cred flow into them. So this time filtering approach, which we called timeline cred, is that first, we're going to consider just the oldest graph, just the graph of stuff that existed before T1. And we're going to run PageRank on this graph. So we've got seed flowing in, we've got some nodes and edges, and nothing from the future. And then we're going to consider the graph which had everything up through T2. And we're going to now only consider the seed as flowing cred into the latest time interval. So sort of the old history of the graph still exists, but new cred only enters in the current time period. And then we're going to run PageRank on this graph. And then finally, we'll consider the last time interval. And once again, we'll construct it where we've got the whole graph, but we're only flowing new cred in this final interval. And then we run the PageRank scores again. And this gave us actually a pretty good result in terms of quality of cred, which is to say we've got these like nice scores. They're defined for every node in the graph. We've got a score for every time period. And your total score is the sum of your score from each individual time period. However, it had two real disadvantages. One is that now we need to run PageRank once for every time interval. And so taking the example of source cred is about 2 years old at this point. And we compute cred on a weekly basis. So we've got about 200 weeks worth of history. And that means we need to run PageRank 200 times every time we want to compute the cred. And if you do something like change the weights on the graph, you need to run PageRank 200 times again. So it's quite expensive, and it makes it kind of prohibitive to, in principle, it'd be really nice to compute cred on a daily time cadence. But that's just impossible if you're doing this if you're running PageRank once for every time interval. The second is that we lose actually a lot of nice properties of PageRank. PageRank scores have this nice property that if you look at any node's score, its score is going to exactly be the sum of how much score it got from each one of its neighbors. And once you're doing this weird thing where you're saying, oh, actually your score was the summation of running PageRank 200 times, you no longer really have nice analytic properties about that distribution. So it makes it harder to analyze the output data. And so what this really suggested is that it would be great if we could have a way of embedding this timing information directly into a single graph rather than using time to factor it into 3 separate graphs. And that is what we did with the algorithm that we're now really fully calling CredRank, which is where we're going to take the graph and embed temporal information into its structure. The basic idea is that now for each participant, rather than having a node in the graph that represents that participant, we're going to have a series of time-scoped proxy nodes in the graph. And let me illustrate this visually. So let's suppose we're taking our same time graph and we've got a participant particular participant, the turtle, who we're interested in. And so the turtle has authored these 5 contributions. And so those 5 contributions all have an edge directly to the turtle. What if instead we make 3 nodes that represent the turtle, and there's 1 turtle node for each period of time? So this first node represented by turtle T0 represents the turtle's contributions in the first interval. This one represents the turtle's contributions in the second interval, and this one represents the turtle's contributions in the third interval. Well, now we actually, just by running PageRank once on this graph, we get a score for the turtle in each particular interval. And we actually once again get this property that we can just sum across to get the turtle's total scores. But we're doing so within a single invocation of PageRank. So the result is that now, no matter how many time intervals you have, you only run PageRank once, and all you have to do is kind of add these extra nodes to the graph. But because there are very few participants compared to contributions, an average participant might have hundreds or thousands of contributions, it has a very small increase on the graph size, while affording us this answer to a really interesting question of when was cred earned. So the net
Dandelion,
result... Yeah, go ahead.
Sorry, could I interrupt again? I know I'm heckling you a lot right now, but I was wondering, here, I'm going to focus your slides again. Doesn't T0 and T1 change when you add in those additional nodes that are in T2? Because some of the nodes in T2 are referencing nodes in T0 and T1. So when you do the recalculation, is it possible that your time, your T0 and your T1 scores change? So that like, okay, so like literally the amount that I earned during T0 is actually going up basically over time as future nodes point back to it.
Yep, and that's actually a huge and deliberate feature of source cred. So I think this is actually one of the most important properties of cred scores is that they're retroactive. And so that means that rather than optimizing your scores today, you want to optimize the long-term value of your contributions. So as an example, let's suppose that today I'm doing a bunch of research on coming up with like a new, more efficient version of this algorithm, say, something that'll make it 10 times faster. But this research is not yet put into production. I haven't even maybe yet come out with the best way to communicate it, so it's not getting used. And so I'm getting very little cred because there are no other contributions pointing to my research. But let's say that next year, people kind of catch up and we start having implementations and there starts to be a bunch of new work pointing to my research. That means that my cred from this year will be retroactively going higher and higher and higher. And so I think that retroactivity frees people to focus on trying to optimize the long-term value of their contributions rather than worrying about whether it's getting referenced right now. You get to think about the long term. And one thing which I'm not going into this presentation is we've got a whole system for distributing tokens to people based on their cred scores. And that token distribution system is also designed to take into account the retroactivity of the scores. An example I like to use a lot is the example of Rosalind Franklin, who was one of the discoverers of DNA and was the person who kind of built the equipment that allowed us to image the double helix of the structure of DNA. But being a woman scientist in the 1950s, she essentially got cut out of the credit and was not awarded the Nobel Prize for her work, even though it really was seminal to that discovery. And one of the things with source cred is because things are retroactive, like if somebody in source cred were to get kind of overlooked or not properly attributed for work that they do, but then a year later, 2 years later, 10 years later, people realize that their work was important and they start adding these missing edges to the graph, then the person whose work went undervalued would both retroactively get a higher score and then would be given large like catch-up payments to make up for the fact that they were underpaid in the past. So it really is a framework for kind of converging on fair distributions on the long term. And you can contrast this to startups or like traditional workplaces where if you do a really good job of negotiating on day one when you're coming into the company, you might get paid like 30% more than your peers. And then you might actually be a huge underperformer, who knows? But because the rewards are not retroactive, it really incentivizes you to make a super good first showing, more so than to just quietly do work of long-term value. But just going back to CredRank, so we have now switched. We're in the process of switching, but we've prototyped and built all this out. And the result is that the cred scores are quite consistent. It's more or less the same whether or not you compute them through this partitioned graph approach or through the embedded time approach. But it's also several orders of magnitude faster to compute. And that opens up the door for like much tighter feedback loops of tuning the weights and then recalculating cred, which is actually something you can do in your browser because it's all written in JavaScript. In fact, maybe I'll just kind of show off the UI. This is the source cred UI for source cred itself. And you can kind of see for each person, you can see where their cred came from. So for me, like some of my largest individual cred events were these events around CredCon that we hosted earlier this year, some like messages I put in the Discord. And then we can actually open up the weight configuration and we could sort of say, okay, what if we decide we're paying developers too much? We want to reduce the amount of cred that gets minted for pull requests. Then we can click recompute. And this is actually still using the old timeline cred approach. So this is running PageRank 200 times in the browser. But after like 40 seconds or so, we'll see some new scores, which is pretty neat. I'll come back to this. But yeah, so I'll just now plug for SourceCred a little bit. It's an open source project that can actually pay you. We've been distributing about $25,000 worth of grain every week for the past year-ish, just entirely using this algorithm. And it's been really cool to have this ongoing experiment in paying people in a totally permissionless way. It doesn't have to be for development work. We've paid people a lot for like art, for posting memes in the Discord, for organizing meetings, for working on partnerships. And I think people really appreciated having this model where, there's no job. You don't need to work a certain number of hours a week or like report to a boss. You just need to be doing stuff that the community in aggregate is finding valuable. And we're starting to see a lot of usage by other communities like MakerDAO or OneHive or Metagame. So we're kind of starting to prove out that this can really be a useful model for communities in general. So yeah, would love for anyone on this call to come say hi. You can check out our website. You can hang on our Discord. We have these community calls every Tuesday at 11. And if we go back to our other source cred instance, it's actually still recalculating, which is really why we need CredRank. This is what it'll be about an order of magnitude or 2 orders of magnitude faster once we finish the swap. But yeah, to end, here's some cool source cred art, and I'll be happy to take questions.
Nice. Wow, it's really, really amazing. Cool. Yeah, I guess I'll turn it over to Michael. Do you have any questions? I know that you've been following Dandelion's work for a while. So what do you think about it?
Oh no, I think it's awesome. I mean, we talked like really, really early on. We were literally looking at like just the whole incentive system and yeah, and I was actually just very skeptical that you could do any kind of currency or token like at all for any of this. And Dandelion convinced me that like, oh no, there actually is a way to do this where it could really be valuable at work. And it's like, it really looks like it's working. And it's taken like a lot of the really difficult things about this kind of direct monetary incentivization and like pulled all the bad parts out and put all the good parts in. It's really nice.
That's super cool. So I have a question actually that came to mind when you were talking about personalized PageRank. I know that, so obviously PageRank comes from, from the work that, early Google people did, and there's a paper on PageRank. And then personalized PageRank is, I also think, something that I've seen in the literature where you sort of do those nodes or those edges that go back to the node that you want to sort of bias towards in your PageRank calculation. But I hadn't heard of the time interval approach before. Was that something that you came up with and you innovated on, or is that also something like, how much of your stuff is basically from like existing research, and how much are you sort of like inventing stuff as you go to solve the problems that you see?
Yeah, I would say, just going through the talk, everything up until we started talking about time was stuff that was built on existing research. And like up to that point, source code was basically like PageRank on a new data set. We didn't find anything in like the literature about computing PageRank scores over time. And so everything since that point has basically been original research by the source cred team. In my mind, this like time filtered graph approach was pretty kludgy. It was something that I implemented in like a month of hacking because I just felt that we needed time scores so that we could turn on source cred and actually begin like dogfooding and paying people with it. However, this embedded time approach, in my mind, is super elegant. And when we have a chance, I want to write a white paper on it because I think it's just like a really neat approach. And there's actually a number of other, there's a fair bit more complexity in the way we pull this off that didn't make it into these slides because it's kind of tune optimizations on top of it rather than the fundamental approach. But yeah, I think that's actually new research.
So one question from the chat that we're seeing is, can negative contributions be punished after the fact? And I guess related to that, if you add nodes into the graph like far in the future, and like the token that you mentioned, the grain, is already given out based on the source credit at a particular point in time, how does recalculation affect that?
Right.
It seems like it might be too late to sort of take it back once it's been given, even if you do want to sort of reconsider what the graph should have been at the time.
Right. So 2 questions here. One is like, is there a negative cred? And the answer, first off, is no. PageRank operates on probability distribution. So this is something people ask all the time, right? And I think it makes a lot of sense to want there to be negative cred because there's sort of this duality, you know, there's pain and pleasure, there's upvotes and downvotes. Why is there not cred and nega cred? And the answer is it doesn't fit very well in the algorithm. PageRank operates on probability distributions, which of course are a distribution of numbers that all sum to 1 and are all non-negative. And because of the requirement that probability distributions only have non-negative components, there's no natural way to put a negative cred score into the system. It would just break the foundational assumptions. I do believe that there's another crypto kind of PageRank based community called Relevant, and they're making a kind of PageRank based forum for like upvoting and surfacing interesting content and discussions. And I believe that the way they've handled downvotes is they actually run PageRank twice. And they kind of run PageRank once on the upvote graph to assign positive score and PageRank once on the downvote graph to assign negative score. I have not dug into the details there, and it's not clear to me how that would work because positivity has this transitivity where, like, for us, if I trust you and you trust Michael, then there's a sense in which I transitively trust Michael. But if I hate you and you hate Michael, it might actually be the case that I like Michael. You know, there's not transitivity there. And so it's not really clear how to put that into a PageRank context. However, I think it is really important that we be able to get the long run incentives right to kind of discourage, taking bounties, for an example. Bounties are something that people often want to use as a way to compensate open source. But I think the model is really broken in part because it really rewards short-termism, where you never want to do any refactoring, you never want to invest in testing, you just want to, as quickly as possible, get the bare minimum feature that meets the spec for the bounty, and then take your money and then go after another project, you know? And if it all falls apart 2 months later, that's not your problem.
It's the worst parts of contracting. It's like all of the worst parts of having contractors do things like wrapped up in one simple thing.
And so going back to this example here with the contribution graph, you know, in this case, we are assigning a bunch of credit to this pull request because the pull request implemented the feature. Now, what if it turns out this pull request, like, yeah, it implemented the feature, but it implemented in a way that was unmaintainable, that had a lot of bugs, and it's going to need a lot of more work to actually be viable? Well, what we would start to see is more pull requests being connected to this feature, because in a sense, this feature wasn't really complete, and it actually needed 5 more pull requests to fix things up. And that means that retroactively, this person's cred from that feature, who wrote the kind of shoddy pull request, is going to keep on getting diluted until eventually they may prove to have only a very small amount of cred because their work didn't stand up very well. So basically, if you do work that needs to get rewritten, the rewrite is going to eat into your cred score. So that kind of helps get the long-term incentive right. You're right, however, that once we distribute a token, that is non-retroactive. We can't go and be like, oh, please give us your tokens back. We decided we don't like your work because you may have sold it to some third party. And so there's this interesting question of, like, it kind of comes down to vesting, I think. Like, how much time needs to go by for a contribution to kind of fully, like, earn in its grain? And I think this is still a pretty active area of research, but it might make sense to have mechanisms where your contribution gets paid only like 10% in the first year and then gets paid a lot more afterwards once it's kind of had a chance to be challenged if it didn't actually deliver on its promise.
Mm-hmm. Michael, do you have any other thoughts or questions?
No, I'm good. I'm good.
So there's one thing in the chat about potentially if you can't use negative numbers because that's not a valid probability. Can you just start at 0.5 and then like make everything below that an implicit downvote? Would that work, or is there's some problem with this approach?
So it's not exactly clear. Like I would say if you started every marginal contribution at a non-zero score. So let's assume that we're going to be giving people reward based on the value of their score. So if the score is 0, you get a 0 reward. If the score is 0.5, you get like half a reward. If we start everything at 0.5, so we're giving everything like half of a full reward, that would mean that if I go and spam, 500 useless GitHub issues or 500 typo fixes, then each one would be getting like half of a reward proportional. And that would just create, we would be back in these models where, I've seen a number of other approaches to this problem where it's like, oh, you'll get 5 points for pull request and 2 points for GitHub issue. And the problem there is it just really incentivizes churning out lots of low quality output. And if we started everything with like a 0.5 score assumption, we would have the same problem.
Yeah, also, wouldn't that mean that like you couldn't have more than 2 things, because it would like if you get more than 2 things above 0.5, you're now going to go over 1. So you have to change that part of the model too, which seems like it would break everything, right?
Yeah, I'm kind of implicitly translating starting everything at 0.5 to like the most reasonable thing that would fit into the semantics of like PageRank and probability distributions. But I agree that in a literal sense, setting up, you can only set 2 things to 0.5 in a probability distribution.
Right. Cool. Anything else you want to mention before we move on to the social part of the event?
Maybe I'll just allude to the fact that the algorithm turns out to be only one small part of the puzzle. Getting the culture and the cultural incentives right is really important. Figuring out how this information gets communicated is really important. Thinking about the governance mechanisms by which the community can change the weights is really important. I think that I am really glad to be able to share this algorithm because I think it's so neat. But it would be naive to think that just having a clever algorithm is enough to produce a functioning social system. It needs to operate also at the level of culture, at the level of expectations, at the level of thinking about distribution of power, and so on and so forth.
Right. And one other thing that comes to mind for me is that it's also not sufficient to just figure out how to allocate credit if there's no people putting funds into the system. Like if the goal is to incentivize people, then you still need somebody to be putting up the money. And then there's a question about like, what are their incentives? And I know maybe you didn't get a chance to get into that part of the talk because you were focused mainly on the cred, not on the grain part of it. But yeah, there's a whole bunch of like really interesting problems to solve, it seems like.
Absolutely. Yeah.
Cool. Well, where can people find out more about SourceCred or like get involved if they're interested?
So I would say basically come to the Discord is the best starting place. You can just go to sourcecred.io/Discord. We have every Tuesday a community call at 11 Pacific. So that would be, I guess, 5 or 6 hours earlier than we are right now. And it's a super welcoming community. We love having new people and just like answering questions. And also in particular, we're right now working on onboarding. Actually, no, we're not really trying to onboard more communities. We're taking a super like deliberate strategy with growth where we figure the worst thing would be to get a really big community starting using SourceCred where they're not really ready to use it in terms of their like community cohesion and alignment, and where we don't have the bandwidth to support them and like having it become a mess. So we're trying to grow very like deliberately and slowly, but we'd love to have new people come in, just like ask questions and get involved in helping develop it. I can't hear you, for us.
Oh, sorry, I muted myself. Thanks. I was going to say thanks a lot for coming in, presenting, and sharing CredRank with us. Super cool. I think I think it's cool to hear more about it, and hopefully it puts a dent in funding and maintainability issues that we're facing.